Actually, a definite integral can be defined in more than one way, but here, as we are already familiar with the idea of antiderivatives, let me use that idea to give a meaning for definite integral. Suppose f is a function having g as an antiderivative. Let f be a function having, let me be more specific, f of x be a function having g of x as an antiderivative. There exists infinitely many antiderivatives, you choose any one of them. Then by definite integral f of x with respect to x evaluated between limits a and b. The notation used is this one. This is the function to be integrated, variable with respect to which integration is to be carried out, lower limit of integration, upper limit of integration. By this we simply mean value of a chosen antiderivative at upper limit minus value of the same chosen antiderivative at the lower limit a. So, g of b minus g of a, where g is an antiderivative for f, will be the value for definite integral a to b f of x dx. To have the idea of this definite integral meaningful, the only condition is this function must have an antiderivative over the interval a b. Outside the interval what happens, I am not bothered, but within the interval the function must possess an antiderivative. No antiderivative means no meaning for definite integral. If there is an antiderivative, if there exists one, there will be many. If there exists an antiderivative, this is how we obtain value of the definite integral. As an example, let me consider the function or the integral, say x plus 3 divided by root of 2x plus 1 to be evaluated between the limits 1 and 2. Very simple exercise. The procedure for evaluation will be, first you obtain the indefinite integral. After obtaining an antiderivative, we will apply this definition and evaluate the difference, get the value of the definite integral. How to obtain an antiderivative of for the function? The procedure will be, we will write the numerator expression as, just to help us in performing division, in bringing the integrand to a simpler form. Let me write it as 2x plus 1, adjustments needed. To adjust the x coefficient, I will get it multiplied by half. Now the constant term becomes half, covers only a portion of this, the portion remaining uncovered is 5 by 2. I will be able to write the integral as integral 1 to 2 of half of root 2x plus 1 plus 5 by 2 into 1 by root 2x plus 1 to be integrated with respect to x between the limits 1 and 2. Carrying out our usual process of indefinite integration, I get half into, I get one of the antiderivatives as half into, for this function which is of the form u to the power half, where u equal to 2x plus 1, integral is u to the power 3 by 2 divided by 3 by 2 into the x coefficient in u 2 plus 5 by 2 into, for this function which is u to the power minus half, integral is u to the power half divided by half into, as before, x coefficient 2. I get this as one of the antiderivatives. Now this is to be evaluated between 1 and 2 to get the value of the definite integral. We will be getting 1/6 of, what is this at 2? 5 to the power 3 by 2, 5 root 5 minus What is the value at 1? 3 to the power 3 by 2, 3 root 3 plus this portion is 5 by 2 into 2x plus 1 power half to be evaluated between 1 and 2. At 2, 5 to the power half minus at 1, 3 to the power half. This is the value of the definite integral. On simplifying, I get 5 by 6 minus 5 by 2. 5 by 6 plus 5 by 2. How much is it? 5 by 6 plus 15 by 6 is 20 by 6 or 10 by 3 root 5 minus 3 by 6 or half root 3 minus 5 by 2 root 3 total minus 3 root 3 is the value of the definite integral. Notice that the value we have obtained is a definite number. There is no arbitrary constant in it. That is why our integral is called a definite integral. The value of a definite integral, unless one of the limits or both the limits are variables, always will be obtained as a pure number. As a next example, let me consider integration of root 1 plus sin x with respect to x between the limits minus pi and minus pi by 2. The procedure: first we obtain an antiderivative, apply the limits in the antiderivative, compute the difference, value is obtained. Same procedure I am repeating now also, but how to get an antiderivative? First let me write the integrand as 1 plus sin x will be written as sin square x by 2 plus cos square x by 2 plus 2 sin x by 2 cos x by 2 or square of sin x by 2 plus cos x by 2 under root dx, which is simply minus pi to minus pi by 2. What is square root of sin x by 2 plus cos x by 2 whole square? Is it sin x by 2 plus cos x by 2? No. Let us be more careful. It is mod of sin x by 2 plus cos x by 2. The function to be integrated is not just sin x by 2 plus cos x by 2, is mod of sin x by 2 plus cos x by 2. I do not know which of the two expressions, sin x by 2 plus cos x by 2 and negative of that, which of these two is going to be positive in the interval. It may even happen that in one part of the interval the positive value is sin x by 2 plus cos x by 2 and in the other part it is minus sin x by 2 minus cos x by 2. We have to examine the situation more closely. How do we get that done? In this example, I have a simpler approach because I have equal coefficients and also I have the arguments equal. The equality of the coefficients is not an important thing. Equality of the arguments is helping me. What I do is I write this as integral minus pi to minus pi by 2 mod of root 2 into 1 by root 2 sin x by 2 plus 1 by root 2 cos x by 2, which is nothing but the expansion of sin x plus pi by 4. So, my integrand becomes root 2 mod of root 2 into sin of x plus pi by 4. Sorry, x by 2 plus pi by 4. I have no right to change the argument from x by 2 to x. It is root 2 sin x by 2 plus pi by 4 under modulus is the function to be integrated. Now, I want to know what exactly is the modulus, what exactly is the numerical value in the interval minus pi to minus pi by 2. Notice that for x between minus pi and minus pi by 2, x by 2 will be between minus pi by 2 minus pi by 4 and x by 2 plus pi by 4 will be between minus pi by 4 and 0. This is a part of the fourth quadrant. Minus pi by 4 to 0 means the later half of the fourth quadrant. In the fourth quadrant, do you have a definite sign for the sine function? Yes, it is throughout negative. Therefore, this is a number which is throughout negative in the interval of integration. Therefore, its absolute value will be negative of what you are having inside is minus root 2 sine of x by 2 plus pi by 4. The function to be integrated is minus root 2 sine of x by 2 plus pi by 4. Now integration becomes simple, and indefinite integral is minus root 2 into minus of cos x by 2 plus pi by 4 divided by coefficient of x in the expression half, to be evaluated between limits minus pi and minus pi by 2. This is minus of 2 comes to numerator, minus 2 root 2, its negative, plus 2 root 2. Value of this at upper limit, cos of x by 2 minus pi by 4 plus pi by 4, cos 0 1, minus value at lower limit, cos of minus pi by 2 plus pi by 4, cos of minus pi by 4 same as cos pi by 4, 1 by root 2, or this is 2 root 2 minus 2 root 2 by 2, 2. This is the value of the definite integral root 1 plus sin x with respect found with respect to x between the limits minus pi by 2. So, our new topic will be definite integrals. A definite integral may be defined in several ways. Because we are already familiar with one idea, antiderivative idea, we will be using antiderivative idea to get a meaning for definite integral. Suppose this is an antiderivative for this function. Then we mean by this we will mean so a definite integral from limit a to limit b of a function f of x is simply the difference is the value of a chosen antiderivative at upper limit minus value of the same antiderivative at lower limit. In between you must not change the antiderivative. Once you use some antiderivative for applying the value b, same antiderivative will have to be used to apply the value a also. The difference found in the same form, upper limit value minus value at lower limit, will be defined to be value of this definite integral. For example, will be, let me first obtain the indefinite integral, let me obtain the antiderivative. What is a method for obtaining the antiderivative? Yes. Yes, what are you suggesting? Let me write the numerator as, yes? Any idea? No, that won't work. What is the method? You have practiced finding integral of a function of this form. Yes? X plus 3 equal to a perfect square, some y square, t square. Okay. Any other method? Rationalize the numerator. multiply numerator and denominator by root x plus 3. It will become x plus 3 by 2x plus 1 into root of x plus 3. What next? Same thing. You could have tried that at the beginning itself. After rationalizing the numerator, getting it as x plus 3 by 2x plus 1 into root of x plus 3. Split the numerator. Write the numerator as some constant times 2x plus 1, the expression in denominator, plus or minus some other thing, constant thing, adjustment. Okay, then one portion will become 1 by root or some constant by root of x plus 3, and other portion will be a constant by 2x plus 1 into root of x plus 3. How will you proceed? Again, you will have to use the substitution x plus 3 equal to t square. Suppose your fraction was, instead of having a radical sign in numerator, you are having radical sign in denominator. Will it be now simpler problem? Will the integration process be simpler now? The earlier one was not difficult. Through substitution x plus 3 equal t square, it is not a difficult thing to get the integration performed. This is another situation. Now what will be your method? One method, or suppose you do not want to use any substitution. You want to obtain the integral directly. Right. You may write this as 1 to 2 of, leave the denominator as it is, write the numerator as some numerical multiple of the expression you are having in denominator. What multiple will give you this x? Half. As a result, the constant term will not be fully covered. A portion of that gets covered. Uncovered remaining portion will be 5 by 2. Now you are able to write the integrand as half of root 2x plus 1 plus 5 by 2 into root of 2x plus 1, or it is nothing but 5 by 2 into 2x plus 1 to the power minus half. This is the function to be integrated, and you can write down the integral without employing any special method, directly using a standard result. Am I right? Yes. The integral for first term is half into 2x plus 1 to the power 3 by 2 divided by 3 by 2 into the x coefficient 2 plus, for the second term, 5 by 2 into 2x plus 1 to the power half, that is root of 2x plus 1 divided by half, or equivalently multiplied by 2, divided by the coefficient of x in this expression 2. This is an antiderivative and indefinite integral. I need evaluation of this between the limits 1 and 2. Applying the limits at upper limit, 1 by 6 of this will be 5 to the power 3 by 2. Agreeable? This is 2 cancel, 5 by 2, 2x plus 1 at 2 is root 5 minus value at lower limit x equal to 1, this will be 3 root 3, 1 by 6 times 3 root 3, one more term to be subtracted, value of this at 1, 5 by 2 times root 3. Any simplification? 5 by 6 plus 5 by 2 is yes. Yes, yes, yes. Is it? Huh? 10 by 3 root 5 minus these two clubbed together 3 by 6 or half minus 5 by 2. Am I right? Is it right? Is it not minus 3 root 3? How much is it? Agreed? We simply found an antiderivative for our function, applied the limits, computed the difference, got the value of the definite integral. Notice that definite integral is obtained as a number, pure number, not involving any constant. It has got a definite value. That is why it is called a definite integral. Okay? Few more problems. Employing the same procedure, we can solve several definite integration problems. Suppose you want integral of, say, 3 minus 2x minus x square with respect to x between the limits. Is it meaningful to ask this question? First, let me check that. Arbitrarily, I have chosen some quadratic. I have put it under the radical sign. Arbitrarily, I have chosen two numbers. Is it meaningful to ask you to evaluate this definite integral? Just analyze the situation. This quadratic, 3 minus 2x minus x square, is a quadratic with x square coefficient negative. So if you try to draw a rough sketch for that, graph for that, you get a parabola with vertex above. You get a parabola symmetric about a vertical with vertex above, somewhat like this. If the x square coefficient is positive, vertex below, x square coefficient negative, like this. This vertex will have x coordinate minus b by 2a. Minus b by 2a. How much? Minus b is 2. Divided by 2a is minus 2. Will it be minus 1? Minus b by 2a. Minus of minus 2 by minus 2. Am I right? It is minus 1. And y coordinate, when x is, I am not considering the radical sign, I am considering only the quadratic. Y coordinate at minus 1, 3 minus 2x minus x square. 3 plus 2 minus 1, 5 minus 1, 4. Okay. When a quadratic is given, when a quadratic with real roots is given, you know the expression takes positive values when x lies where? Or I do not require that idea. I have already drawn the sketch. From the sketch I find y coordinate for the vertex is positive. The graph is symmetric about a vertical and lies below the vertex. So after a certain level, y coordinates start becoming negative. Only up to this level I get y coordinate positive. Below this level, y coordinate is negative. I am trying to integrate from 0 to 1. That means somewhere on this side I have 0 or on this side. On this side I have 0. I have 1 also on this side. In that interval I want to know whether this is positive or negative. If this is positive, my expression will be meaningful. There will be some meaning in asking for value of the definite integral. If in any portion of that interval this becomes negative, then this function will be undefined. There is no meaning in determining the value of the definite integral. Okay? At x equal to 0, what is the value of the expression? 3. Agreeable? At x equal to 1, 0. So we are not crossing this point. If I choose a value greater than 1, at that point this expression 3 minus 2x minus x square will become negative and the function will become undefined. There will be no meaning in finding the value of the definite integral. As far as this interval 0 to 1 is considered, the expression remains non-negative. So there is a meaning in evaluating the square root, there is a meaning in performing integration and also obtaining the value of the definite integral. Let us try to evaluate the definite integral. Method will be completing squares. Applying the corresponding formula for integral of root a square minus x square dx, I get x by x is x plus 1 by 2 into root of whatever you are having here, 3 minus 2x minus x square plus a square by 2, 4 by 2, 2 into sine inverse of x by x is x plus 1 now, divided by a is 2. The expression is to be evaluated between the limits 0 and 1. At x equal to 1, value will be, this will be 0, so this product will be 0. This will be 2 sine inverse 2 by 2, 2 sine inverse 1, but sine inverse 1 you know is pi by 2 into 2 is pi. Value of the integral at upper limit is pi. At lower limit, 1 by 2 into root 3 by 2, and this at lower limit 2 sine inverse half, 2 into, what is sine inverse half? Pi by 6, or it is 2 pi by 3 minus root 3 by 2. I find my integrand in a standard form. Integrand is in the form e to the power ax sin bx with x replaced by a linear expression a and b, two numerical constants. What are a and b? What is the linear expression replacing x? You may write this as 2 by 3 to 4 by 9 e to the power 2 into 3x minus 1 sine of 3 into 3x minus 1 dx. I find my expression in the form e to the power 2x sine 3x with x replaced by 3x minus 1. What is a formula for integral e power 2x sine 3x? It is e to the power ax, in this case e to the power 2 into 3x minus 1 divided by a square plus b square, 2 square plus 3 square, 13 into a sin bx. A is 2, sin bx is 3 into 3x minus 1 minus or plus minus b cos bx. B is 3, cos bx is 3 into 3x minus 1. Is it over? No, not over. We have obtained this applying the formula for integral e power ax sin bx. Our function was not simply e power ax sin bx. We had a x replaced by another linear. The coefficient of x in that linear is 3, will have to be inserted somewhere in the denominator. This expression needs evaluation between limits 2 by 3 and 9 by 4. Applying the values at 9 by 4, is 4 by 9. At 4 by 9, 4 by 3 minus 1, 1 by 3 into 2, 2 by 3. 3x minus 1 will be 4 by 3 minus 1, 1 by 3 into 3, 1, 2 sin 1 minus 3 cos 1 is the value at upper limit 4 by 9. At lower limit 2 by 3 value will be 3 into 2 by 3, 2 minus 1, 1 into 2 e power 2 divided by 39 into x equal to 2 by 3. This is 2 by 3 into 3, 2 minus 1, 1 into 3, 2 sin 3 minus 3 cos 3. I don't think we can try any simplification on this. Leave it like this only. This is the value of the definite integral. In our next problem, we have our integrand as 1 plus sin 5x by 1 plus cos 5x. How to perform integration of 1 plus sin 5x by 1 plus cos 5x? Our limits are 0 and pi by 10. Is my integrand well defined throughout the interval of integration? Yes. When x lies between 0 and pi by 10, 5x will be between 0 and pi by 2. Nowhere this denominator will become 0. Agree? So there is meaning in trying integration of this. How to integrate? A method may be. There are several methods. One simplest method may be some sort of not rationalizing. We multiply numerator and denominator by 1 minus cos 5x. As a result, denominator will become sin square 5x and numerator or one other method may be instead of multiplying or going for a double angle formula, how about using the same formula with in a converse way? in an opposite way. Instead of multiplying directly as it is, you apply a half angle formula for this. What will it be? 1 plus cos theta is well known to you as 2 cos square theta by 2. In numerator, I leave this 1 as it is. No need to write it as sin square 5x by 2 plus cos square 5x by 2. Leave it like that only. Write this only as 2 sin 5x by 2, 5x by 2 cos 5x by 2. Now each term becomes directly integrable. First term is half of secant square 5x by 2. Integral is tan 5x by 2 divided by 5 by 2. Second term is simply tan 5x by 2. Integral of which is log of secant 5x by 2. Again, because you have your x coefficient not equal to 1, you will have to divide by 5 by 2. This is an antiderivative is to be evaluated between 0 and pi by 10. At pi by 10, 5x by 2 is pi by 4. Tan of that is 1 plus 2 by 5 into 5x by 2 is pi by 4 as before. Secant pi by 4 is root 2. Log of that, I may write it as half log 2. This is what I get at upper limit, pi by 10. Next at lower limit, 0. This is tan 0, 0. This is secant 0, 1. Log of which is 0. If you want, you may combine the two terms. You may write it as 1/5 of log 2e. Minus pi to minus pi by 2 root of 1 plus sin x dx. A method for carrying out integration is write 1 as sin square x by 2 plus cos square x by 2, sin x as 2 sin x by 2 cos x by 2. See the expression under the radical sign is a perfect square, so that removal of the radical sign will be possible for you. Minus pi to minus pi by 2 root of sin x by 2 plus cos x by 2 whole square. But now, while removing the radical sign, you will have to be little more careful. Root of a number can have two values. It may be positive square root or negative square root. That is for square root. In this case, I am writing root of a certain number. I am compelled to take the positive root alone. For this number, there may be two square roots. One is sin x by 2 plus cos x by 2. Another is minus sin x by 2 minus cos x by 2. But for this, I mean only the positive square root. So among the two square roots you have to select the positive square root and use it as the integrand of this definite integral. What is the positive square root of sin x by 2 plus cos x by 2 whole square? Is it sin x by 2 plus cos x by 2 or minus sin x by 2 minus cos x by 2? Remember, your interval of integration is minus pi to minus pi by 2. Is not a part of the first quadrant, is not the first quadrant, is actually which quadrant? Third quadrant. When x lies between minus pi and minus pi by 2, this argument x by 2 will be between minus pi by 2 and minus pi by 4. Now you are not getting a portion of third quadrant, you will be in fourth quadrant. Minus pi by 2 to minus pi by 4. This is your region of integration. In this region, which expression is positive? Sin x by 2 plus cos x by 2 or minus sin x by 2 minus cos x by 2. You may take the help of graph. You know interval is minus pi by 2 to minus pi by 4. At minus pi by 2, cos is 0, cos at this point is 1 by root 2. Am I right? Graph may be something like this. Okay. Sin at minus pi by 2 is minus 1. At minus pi by 4 is minus 1 by root 2. Graph will be this. Now question, which of these has or is steeper? Which is increasing at a higher rate and which is increasing at a lower rate? Knowing that, you will be able to decide which difference is positive, which difference is negative. Let me complete the graph. Let me extend the graph up to 0. This will go up to 1 and this will go up to 0. Will the two be sort of parallel to each other? No. Actually, what will be? I have wrongly drawn the graph, I think. Yes. Yes. If you draw the complete graph, this is the graph of cos. You are considering this portion. This is the graph of sin is sorry, somewhere I have gone wrong. Oh, my scale is different. No, this width has gone. One second. This is 0, pi by 2, pi, 3 pi by 2, 2 pi. Okay. This is the graph of cos. And we are interested in which portion? In this portion. Agree? This portion or later portion? This, exactly this. Correct. And sine graph will be, okay, our portion of interest is this. Are these parallel to each other? No, they are not. Which difference will be positive? Which sum will be positive? Cos x by 2 plus sin x by 2 or minus of cos x by 2 and plus sin x by 2. It's clear now. Okay, because this depth is more than this height. This is a positive quantity, this is a negative quantity. Negative quantity is more. Throughout the interval, this negative has greater magnitude. The positive square root will not be sin x by 2 plus cos x by 2. Instead, will be minus cos x by 2 minus sin x by 2. One simple argument to just to guess the positive square root may be, just consider some arbitrary well-known angle belonging to the interval minus pi by 2 to minus pi by 4. Say minus pi by 6. Minus pi by 6 or 5 pi by 6. Minus pi by 3. At this point, you just determine what is sin theta plus cos theta. You will be knowing what the which of the two expressions is positive, which is negative, easily. Okay. So this is what I am supposed to integrate. On integrating and applying the limits, I get my answer. This will be minus cos x by 2 by half. Am I right? minus sin x by 2 divided by half. Limits are pi, minus pi and minus pi by 2. Minus of minus plus 2 into cos minus pi by 4 is 1 by root 2 minus 2 into sin of minus pi by 4 minus 1 by root 2 is the value at upper limit. Value at lower limit will be, this will be 0 and this will be minus 1. Minus of minus 1 divided by half, that is 2. 0 to pi by 2 sin 2x divided by cos of pi by 4 minus 2x. Method. One method may be, you write the numerator as 2x minus pi by 4 plus pi by 4. Treating it as an expression of the form sin a plus b, expand it. Expand it as sin a cos b plus cos a sin b. You will be able to decompose the integrand and you will be able to perform integration term by term. First part will be sin of 2x minus pi by 4 into sin pi by 4 divided by this will be tan of negative of tan of 2x minus pi by 4 sin pi by 4. Next part will be cos pi by 4 minus 2x, cos pi by 4 minus 2x cancel. A constant, it will be simply cos pi by 4. Cos or sin, some one of the trigonometric functions of pi by 4. One method. Another simpler method may be, because this is a well-known angle, expand. If the denominator is something like cos 1 minus 2x or cos of 3 minus 2x, you will have to use my earlier method. There is no other choice. But now, because this is an angle for which you know both cos and sin values, you can simply expand and write am I right? Cos a cos b plus sin a sin b. Am I right? Cos a and sin a both will be 1 by root 2 each. So root 2 goes to numerator. Okay, how to continue? One method, tan x equal to t. I want to avoid substitution at this stage. Okay, total avoiding of substitution may be difficult. Okay, any simpler substitution, simpler than your tan x equal to t. Cos 2x equal to t. But this will become root of 1 minus t square, an irrational expression. Why unnecessarily irrationalize the denominator? You have a standard method. Whenever you have an expression of the form a sin x plus b cos x divided by c sin x plus d cos x. Method is, write the numerator as some constant into denominator plus another constant into derivative of denominator. You will require a small substitution, but that is a more straightforward substitution. Integration will be immediate in that case, once you get the constants, coefficients k1 and k2. Let me leave the denominator as it is and write the numerator as some constant into cos 2x plus sin 2x plus another constant into derivative of denominator minus 2 sin 2x plus 2 cos 2x. For what values of a and b numerator will be equal to sin 2x. Root 2 I have retained outside. You want a minus 2b to be 1 coefficient of sin 2x and a plus 2b to be equal to coefficient of cos 2x 0. So a must be adding 2a equal to 1, substituting 2b equal to minus half or b is equal to minus 1 by 4. Now integration becomes immediate. Integral is root 2 into integral of first part x minus root 2 by 4 into integral of second part log of denominator cos 2x plus sin 2x. This is the expression to be evaluated between limits 0 and pi by 2. Root 2 by 2. So it will be 1 by root. Applying the limits, x between 0 pi by 2 is pi by 2 root 2. Amount to be subtracted corresponding to this lower limit is 0. This at upper limit cos pi, how much? Minus 1 plus sin pi 0. Log minus 1 is undefined. So what should we say? Should we claim integration is meaningless? Yes. Integration formula has not been properly applied. For this dt by t, integral is not just log t, it is log of mod t. Usually we do not consider that modulus, we neglect it and write it simply log t, but when necessity arises, you will have to bring in that modulus. It becomes log of mod minus 1, log 1, 0. At lower limit, this is cos 0, 1, this is sin 0, 0. Again you are getting log 1 whose value is 0. Therefore, answer is simply pi by 2. Nothing to be removed, nothing to be subtracted. This is a more simple, more straightforward problem. A integration problem which is to be integrated by the method of integration by parts. You may prefer to apply the extended form of the rule of integration by parts. First function into integral of the second minus cos x minus derivative of first into integral second minus sin x plus derivative of first into integral second cos x. If I go wrong anywhere, correct me. Minus derivative of first into integral second sin x. Integration is finished and this is to be evaluated between the limits 0 and pi by 2. At pi by 2, cos pi by 2 0, this cos pi by 2 also 0, only terms to be recorded are these two. In each case sin pi by 2 is 1, so value will be minus of minus plus 3x square 3 into pi square by 4 minus 6 is the value at upper limit. At lower limit sin x is 0, sin x is 0, this x is 0, this x is 0, so entire expression is 0, amount to be subtracted 0, this is the value of the integral. This is another situation where you will require the method of integration by parts, but now you will not prefer the extended form, you will apply only the basic form. Applying the basic form you get first function log x into integral second x cube by 3 minus integral derivative of first 1 by x integral second x cube by 3 dx. This portion has already been integrated. Apply the limits 1 and e. In the second portion, integration symbol is still remaining with the limits 1 and e. Value will be at e log e1 e cube by 3 at 1 log 1 0, amount to be removed, subtracted 0, minus integral of x square by 3 is x cube by 9, 1/9 of x cube between the limits 1 and e is e cube minus 1, which is equal to e cube by 3 minus e cube by 9 is 2 e cube by 9 minus of minus plus 1 by 9. Next, I have a situation where I cannot avoid integration by substitution method. I have to use the method of substitution, carry out integration. The substitution which helps us in the evaluation is minus x cube equal to t. When the substitution is applied, integrand becomes e to the power t into x square dx is minus dt by 3. One slight variation that we will adopt in the evaluation of a definite integral by the substitution method is, when you apply substitution, not only the integrand changes, simultaneously these limits also will be changed. We will bring in new limits of integration so that at the end there will be no necessity to get back to the original independent variable. With the new variable itself, we can finish our job and get our number or value of the definite integral. At x equal to 1, t value is minus 1, that will be our new lower limit. At x equal to infinity, t value will be minus infinity, and that will be our new upper limit. So this is what we are required to carry out. When you adopt this policy of changing the limits also together with the variables, there will be no necessity to get back to the original variable x at the end of the problem. Okay, carrying out integration, minus 1/3 of integral is e to the power t, to be evaluated between minus 1 and minus infinity, and it is 1/3 of e power minus infinity, 1 by e power infinity is 0, minus e power minus 1 is 1 by. So how much I am getting finally with plus sign, right? Next, integration of sin cube x cos cube x between the limits 0 and pi by 4. One more situation where we have to depend on method of substitution. Substitution ideal to apply maybe, yes, cos x equal to t or sin x equal to t, or still better substitution may be
sin cube 2x by 8.
sin cube 2x by 8. Oh, this can be written as, okay, repeatedly applying the formula for 2 theta, sin 2 theta. Or not repeatedly, applying only once. Writing sin x cos x as half of sin 2x. You are getting sin cube 2x by 8. What next? Use the formula for 3 theta. Okay. The idea I had in my mind is use of the substitution t equal to sin square x. What happens? One part of this first factor sin square x is t. One part of this second factor cos square x is 1 minus t. And the remaining portion sin x cos x dx is half of dt. And limits, new limits, At x equal to 0, t is sin square 0. At t equal to pi by 4 upper limit, t new value sin square pi by 4, square of 1 by root 2, 1 by 2. Integral will be half of integral t is t square by 2, integral t square is t cube by 3. Limits 0 and half. Applying the limits, 1/4 of 1 by 4, 1 by 16, at lower limit value is 0, 1/6 of 1 by 8, 1 by 48. Next, 0 to pi dx by 1 plus 2 sin x plus 3 cos x. Again, you may have several methods. One of the methods is use of substitution tan x by 2 equal to t. The new limits of integration will be tan 0, 0 and tan pi by 2 infinity. Notice that in our integration process, x is tending to pi from below. Therefore, x by 2 will be tending to pi by 2 from below. Therefore, tan theta will be tending to infinity from positive side. It will not be minus infinity, instead it will be plus infinity. Okay? And when the substitution is applied, dt becomes 2 dt by 1 plus t square, 1 plus 2 into 2t by 1 plus t square, plus 3 into 1 minus t square by 1 plus t square. And on simplification, I am getting my integrand as 2 dt by 1 plus t square plus 4t plus 3 into 1 minus t square is 1 plus 3, 4 plus 4t plus t square minus 3t square minus 2t square. Or my integrand is 1 by or minus 1 by t square minus 2t minus 2. You have arrived at a quadratic in the denominator. First you check whether this quadratic is factorizable. If it is factorizable, we will prefer the method of partial fractions. If it is not factorizable, we will go to the method of completing squares. Is this a factorizable expression? No. So, we will apply the method of completing squares. We will get minus 1 by t minus 1 whole square minus 3. On applying a formula, minus 1 into 1 by 2a log of t minus 1 minus root 3 divided by t minus 1 plus root 3 to be evaluated between 0 and infinity is minus 1 by 2 root 3 into log of, at upper limit, log of 1. When you apply the value t equal to infinity, this becomes infinity by infinity and indeterminate. How do you avoid getting that indeterminate? Get the numerator and denominator divided by a t first. Get this as 1 minus 1 by t minus root 3 by t by 1 minus 1 by t plus root 3 by t. Now you apply t equal to infinity, you get log 1 which is equal to 0. Minus at 0 value is, you need a modulus, insert it, log of root 3 plus 1 by root 3 minus 1. This is 1 by 2 root 3 of log of root 3 minus 1 by root 3 plus 1. If you want, you can further simplify this, rationalizing the denominator. Yes? Huh? Okay. Sorry. Yes. Right. This integral is integral half to 2 1 minus 1 by t square 10 to the power t plus 1 by t dt. Clearly, from the form of the integrand, we find the ideal substitution is substitution t plus 1 by t equal to y. When you use that substitution t plus 1 by t equal to y, you will get the equivalent of dy as 1 minus 1 by t square dt. For that substitution, the corresponding new limits will be, when t equal to half, y will be half plus 1 by half equal to 5 by 2. Half plus 2 equal to 5 by 2. New upper limit will be t equal to 2, 2 plus 1 by 2 equal to 5 by 2. You are getting lower limit equal to upper limit. Conclude that value is 0. Before proceeding, a geometric meaning for definite integral. Geometrically, integral a to b f of x dx represents the area bounded by graph of y equal to f of x, the ordinates at x equal to a, x equal to b, and the x-axis. If this is the graph of y equal to f of x, this is the x-axis, these are the ordinates at x equal to a and x equal to b, this area is represented by this definite integral. This definite integral represents this area, provided there is a condition, there is a clause, this graph must not cross the x-axis between a and b. It may, later onwards, it may cross the x-axis, no problem. Here, it may cross the x-axis, no problem. But in between x equal to a and x equal to b, graph must not cross the x-axis. The graph must not be like this. In this case, this total area will not be obtained by that definite integral, provided the graph does not cross the x-axis. This area is exactly represented by this definite integral a to b f of x dx. One sort of justification I can provide. Take an arbitrary point x belonging to the interval. Consider this area bounded by the curve, the ordinates at x equal to a and x equal to x, and the x-axis. Clearly, the value of this area, the magnitude of the area, is a function of x. As x moves, as this ordinate moves, the size of the area also changes. If you move to the right, area will be increasing. If you move to the left, area will decrease. It's clearly a function of x, so I may denote it by a of x. Agreeable? Give to this x a small increment delta x. Draw a vertical at x plus delta x. This new area now will be area bounded by x equal to a, x equal to x plus delta x, x-axis and graph will be a of x plus delta x. Therefore, a of x plus delta x minus a of x will be area of this thin strip. Agree? Suppose you divide it by delta x, area divided by delta x it will be. And you want to obtain its limit as delta x tends to 0. When delta x tends to 0, the width of the strip decreases. You can identify this strip as a rectangle with certain height and certain width. The width is delta x and height is y, f of x. Therefore, that difference divided by delta x, area divided by delta x will be equal to the height of this strip, which is equal to y or f of x. This means derivative of a with respect to x is y. Therefore, one expression for a of x must be integral of y from limit a to x. That will be a of x. A of x is integral a to x of y dx or f of x dx. If you want the area up to b, then you will have to replace x by b. Then you will get the definite integral a to b f of x dx. Okay. This interpretation applies as long as this curve is not crossing the x-axis between the ordinates a and b. Actually, to determine the area of a trapezium, you have a very simple formula. I want to use integration and obtain the area. What is the area I am required to find? It's trapezium with vertices 2, 0, 3, 0, 3, 2, and 2, 5. This is the area I am required to determine. What I do is simply obtain the equation of this line. What is the equation of this line? Using the 2-point formula, y minus y1 equal to slope into x minus x1. What is the slope? y1 minus y2 by x1 minus x2. Or the equation of this line is y equal to 2 minus 3x plus 9 or 11 minus 3x. Because I am finding line is not crossing the x-axis between the two ordinates, the area is obtainable as a definite integral. The area is simply integral of y, that is 11 minus 3x to be carried out with respect to x between the limits this number and this number 2 to 3. And clearly it is 11 into 1 minus 3 by 2 into 9 minus 4, 5. Yes, sir. 7 by 2. By applying your geometric formula also, do you get the same thing? Half of y1 plus y2 into distance between the two. This is 5 plus 2, 7. Distance is 1 into half. What is the area? Formula for area of a circle with center, the center anywhere with radius r. Area of a circle with radius r. You have any derivation for that? How do you know that? The area is given by that formula. For sake of convenience, I choose the center to be origin. By symmetry, I find I need obtain only this area. Multiplying this area by 4, I get the total area. What is this area equal to? Obtain the equation of this curve in the form y equal to f of x. The equation of the circle with center, origin, radius r is x square plus y square equal to r square, or y square equal to r square minus x square, or y equal to plus or minus root r square minus x square. For the upper portion, the sign to be chosen is plus. Y equal to plus root r square minus x square. So, my area will be 4 times. Function to be integrated is r square minus x square, variable x, y dx. Limits are x at this point 0, x at this point r. You have a ready-made formula for integrating root r square minus x square? Yes, apply it. Formula is x by 2 into root of r square minus x square plus a square by 2 is r square by 2 into sine inverse x by r. Am I right? Limits are 0 and r. On applying the limits, I find at x equal to r, this is 0. This is r square by 2 into sine inverse 1. Sine inverse 1 pi by 2. 4 into half into pi by 2 is pi r square. At x equal to 0, this is 0, this is sine inverse 0 equal to 0, therefore the formula is pi r square. This integration could have been little easily performed had you used parametric representation for this circle. Parametric representation for circle with center, origin, radius r is x equal to r cos theta, y equal to r sin theta. Could have used this expression for y and used this for finding dx. Could have got the integrand in a still simpler form. Integration, applying the limits gets you that form. What is formula for area of an ellipse? Ellipse with semi-major axis A, semi-minor axis B. You can obtain it applying integration. How? Again, as before, there is symmetry. We need find only this area. Get it multiplied by 4, you get your required area. How to determine this area? Sake of convenience, you choose this as origin, this as x-axis and this as y-axis. Equation of the ellipse will be x square by a square plus y square by b square equal to 1. Now for a change, let me use parametric representation. Parametric representation for this ellipse is x equal to a cos theta, y equal to b sin theta. Am I right? Do you get x square by a square plus y square by b square equal to 1? Yes, you get it. The function to be integrated is y, b sin theta. Differential is dx. dx is a into minus sin theta d theta. Limits are lower limit x equal to 0. X equal to 0 means a cos theta equal to 0. A cos theta 0 means theta equal to pi by 2. Upper limit x equal to a, x equal to a means a cos theta equal to a cos theta equal to a means theta equal to 0, cos theta 1, theta equal to 0. Or you may use this also. At this point y is equal to b, y is equal to b, y equal to b means sin theta equal to 1, sin theta equal to 1 means theta equal to pi by 2. At this point y equal to 0, y equal 0 means sin theta 0, theta equal to 0. Okay. 4ab minus of 4ab, integration of sin square theta. Sin square theta is nothing but 1 minus cos 2 theta divided by 2. The limits are pi by 2 and 0. Or integration, I am getting minus 2ab into integral 1 d theta from 0 to pi by 2 to 0 is minus pi by 2. Other portion, when integrated, gives you sin 2 theta. Sin 2 theta is 0 both at upper limit and lower limit. Sin 2 theta is 0 at theta equal to 0, also at theta equal to pi by 2. Next, before proceeding with more problems on evaluating definite integrals, let me list some of the important properties of definite integrals. There are many situations, many numerical problems where using properties alone we will be able to evaluate, get the value of the definite integral. There will be no need to carry out any integration. With the help of properties alone, values are obtainable. So, just to get advantage of that situation, let me first list the properties, then proceed with more problems on definite integrals. Properties of definite integrals. Some of the important properties. First property says, value of a definite integral has got nothing to do with the variable, the symbol you are using to represent the variable. By whatever name you call that variable, value of the definite integral will be the same. Whether you integrate sin x with respect to x between 0 and pi by 2, or sin t with respect to t between 0 and pi by 2, or sin y with respect to y between 0 and pi by 2, you are going to get the same answer. Whether you are integrating f of x with respect to x or f of t with respect to t, as long as function is the same, lower limits are same, equal, upper limits are equal, value is going to remain the same. Value is dependent only on three things. One is form of the function, the size of the lower limit, size of the upper limit. For example, one more symbol I want. You do not know how to carry out this integration. You do not know how to integrate sin x square. But using the property, you can conclude that the expression, the value of the whole expression must be equal to 0. Because all the integrals involved are numerically one and the same. This is some quantity, say a. This is same quantity subtracted, same quantity added, same quantity subtracted. To obtain the value of this expression, there is no need to carry out each integral. Just to notice that, suppose you apply a substitution on this integral. The substitution you need apply is x equal to tan theta. What will happen to the integral? It will become 1 plus tan square theta secant square theta whole square secant power 4 theta in denominator, and in numerator secant square theta d theta. Cancel the secant square, shift the remaining secant square of denominator to numerator. It becomes cos square theta d theta. New limits will be when x equal to 0, tan theta 0, theta is 0. When x equal to 1, theta is pi by 4, upper limit is pi by 4. So this is same as integral cos square theta d theta from 0 to pi by 4. Coming to this. Instead of trying x equal to tan theta, suppose you try x equal to cot theta, what happens? This becomes minus cosecant square theta d theta divided by 1 plus cot square theta whole square. 1 plus cot square theta is cosecant square, its square cosecant power 4, cosecant square cancel, remaining cosecant square you shift to numerator. It becomes minus sin square theta d theta. With new limits, when x equal to 0, cot theta 0, theta is pi by 2, upper limit. When x equal to 1, cot theta is 1, theta is pi by 4. You will get lower limit pi by 2, upper limit pi by 4. In any integral with lower limit a, upper limit b, suppose you interchange the limits, what happens? Okay. Therefore, this is negative of the value of this. Agree? But there is one more negative sign here. Taking this into consideration, we find this and this are equal. This and this are equal. Therefore, the whole expression is simply one more illustration. This is an integration which you cannot perform. This is an integral whose antiderivative involves non-elementary functions. Therefore, integration cannot be performed by us. But the compound expression that I am going to write now will be obtainable easily with the help of one of the properties. Suppose you call this I. In this you apply the substitution log x equal to t. What are you going to get? Log x equal to t means x is equal to e to the power t. Therefore, dx will be e to the power t dt. Log x is t. New limits are when x equal to e to the power t equal to e, t is 1. When x equal to e square, e to the power t equal to e square, upper limit 2. You will be getting integral 1 to 2 e to the power t by t. Do you find it anywhere? Yes. So, if this is I, this will be minus 3i. What about the remaining two? In this integral e power t by t 1 to 2, suppose you apply substitution t equal to y square. You will find the integral as e power y square by y square into dt is 2y dy with the new limits t equal to 1, y is 1, t equal to 2, y is root 2. Therefore, integral 2 into e power y square by y dy between 1 and root 2. This whole thing will be equal to I. Including the coefficient 2, it is I. Okay, what about the last? Yes. Yes. X is equal to root t in this original one. Okay, if you put x equal to root t or t equal to x square, x is equal to t square, not t equal to x square, x equal to t square. Yes, root x equal to t or x equal to t square. Right. If you apply this, integral becomes 2t dt divided by log x log t square is 2 log t, new limits being x equal to t square, x equal to e, t is equal to root e, x equal to e square, t is equal to e. So, root e to e, t by log t dt is another form of the same integral I. Therefore, the whole expression value must be 0. None of the integrations are individually performable, but the whole expression you can evaluate. Next property we have already noticed it is integral a to b f of x dx is equal to minus of integral b to a f of x dx. This also is one of the very important properties. We will be using this several times later in our applications. So, no separate illustration I will be giving now. Next property. There is no rule that C must be a number between A and B. C may be anywhere on the real line, but only requirement function must be integrable in each of the three intervals. In order to write integral A to B as A to C plus C to B, function must be integrable over AB, integrable over AC, integral over CB. For example, suppose you have integral of a root of x minus 1 into x minus 2 dx from 3 to 4. Is this a meaningful integral? Yes. X is outside the interval. As long as x is outside the interval 1 to 2, expression will be positive, square root will be meaningful. Our interval is from 3 to 4, no problem. I cannot write, quoting that property, I cannot write this as 3 to 0 plus 0 to 4, it will be wrong. Because this will be an interval in which this function is not completely defined. It is defined only outside the interval 1 to 2. So, in the entire interval 0 to 4 or 3 to 0, 0 to 3, I cannot find a meaning for this integrand. So, it is wrong to quote that property and write the integral like this. As long as integrations are meaningful over each of the intervals of integration, the property is applicable. You can further subdivide the interval of integration. You can even write integral a to b f of x dx equal to a to c1 plus c1 to c2 plus c2 to c3 plus cn to n minus 1 to cn plus cn to b f of x dx. Only requirement for the first integral, lower limit is same as this lower limit. For the final integral, upper limits upper limit will be same as this upper limit. In between, these two will be equal, these two will be equal, this will be equal to the lower limit of the next integral, these two will be equal, so on. Again, condition, in each of the intervals, function must be integrable. Then only this expansion applies. In order to perform integration, I must get rid of modulus. How to get rid of modulus? You know, by definition, mod x is x if x is greater than or equal to 0, minus x if x is less than 0. Definition changes at the point x equal to 0. Is 0 an interior point of the interval? Yes. Break the interval at that point. In this interval, the meaning of mod x will be minus x. In this interval, it is x. Now it's straightforward integration, application of limits. This expression changes sign at 1 and 2. Among the 2 points, the only interior point of this interval is 1. You need break the interval at only one point, that is the point x equal to 1. Within the interval 0 to 1, x minus 1 is negative, x minus 2 is negative, the product is positive. So the integrand modulus will be x minus 1 into x minus 2. In this interval 1 to 2, x minus 1 is positive, x minus 2 is negative, product negative. So modulus will be minus of x minus 1 into x minus 2. Integration straightforward. You have just to remove the brackets, expand, term by term integration, applying the limits. X minus 1 negative, x minus 2 negative, x minus 3 negative. X minus 1 positive, negative, negative. X minus 1 positive, x minus 2 positive, x minus 3 negative. Same idea. 0 to 1, 1 to 2, 2 to 3 and 3 to 4. In interval 0 to 1, this is x, this is 1 minus x, 2 minus x, 3 minus x. Total is 6 minus 2x. Is 6 minus 2x throughout positive in this interval? It vanishes at 3. 3 is an exterior point of the interval. So this 6 minus 3x will be taking the same sign throughout. Which sign? Positive or negative? Positive. Agreed? In the interval 1 to 2, this is x minus 1, this is 2 minus x, this is 3 minus x. Agreed? Yes. It will be simply 4. Mod 4 is 4. Okay. In the interval 2 to 3, this is x minus 1, this is x minus 2, this is 3 minus x. You will get 2x, just that much. Okay. Mod 2x you are getting. Mod 2x is 2 into mod x. What about mod x in the interval 2 to 3? Is x. In 3 to 4, this is x minus 1, x minus 2, x minus 3, 4x minus 6. Is 4x minus 6 positive in the interval 3 to 4? 4x minus 6. Yes. Let me have the upper limit as 3. First we will remove the innermost modulus by breaking the interval of integration into two pieces, 0 to 2 and 2 to 3. In the interval 0 to 2, x minus 2, mod x minus 2 is 2 minus x. Agree? In the other interval, integrand is mod of x plus mod of x minus 2 dx. This is cancel. Mod minus 2 is 2. Am I right? Mod of x plus 2. Yes. 2x. 2x minus 2. Okay, then there will be a necessity to break it further. Mod of x plus mod of x 2x minus 2. Okay. Correct. 2. This is an expression which vanishes at x equal to 1. Is 1 an interior point of the interval? Yes. So this interval will have to be further broken into two parts, 0 to 1 and 1 to 2. In 0 to 1, 2x minus 2 is negative. So modulus will be 2 minus 2x. X plus 2 minus 2x is x plus 2 minus 2x is 2 minus x. Is 2 minus x throughout positive in this interval? Yes. No need to place it under another modulus pair. This is nothing but mod x plus 2. Is mod x plus 2 throughout positive in the interval? Yes. Oh, one part I forgot. Sorry. Okay, 1 to 2. The other part, in this interval, x minus 1 is positive. So this is 2x minus 2 plus x is 3x minus 2. Is 3x minus 2 throughout positive in this interval? Yes. Because the only point where this vanishes is 2 by 3 and it is outside this interval. minus 1 to 0, 0 to 1. In the interval minus 1 to 0, integer part is minus 1. In the interval 0 to 1, integer part is 0. Minus 2 to 0 plus 0 to 3. In the interval minus 2 to 0, signum is, in the interval 0 to 3 it is, okay. More examples will follow in tomorrow's session. Many more examples you have to cover on this topic. Later we will continue with more problems.